So we'll talk about planning Cassandra cluster deployment. We'll talk about different options to be considered while deploying a cluster. So what all things you'll have to consider while planning are, the first one is capacity planning. So you'll have to make sure the hard disk or the RAMs or the number of systems that you are using, number of nodes you are using, it is as per your application needs. You shouldn't end up using a lesser capacity because that might impact the basically the performance out of your cluster, or you may not end up spending too much on the infrastructure part of it. So it should be planned as per the application needs. And then hardware selection is very important. You may go for an SSD hard disk or a spinning hard disk, depending on the requirements that we have. Okay, and then we have to plan for key space options. I mean, there are certain options that you can set at key space level, so we have to look into those as well. Replication factor being one thing. Okay, then we have node conf tool. Basically it's a node conf. Basically we have to take care of configuration in each node. We have to make sure the configuration is as per the application needs. And sometimes default settings work, but most of the times you have to change it as per your needs, so that you can make it faster, and so that you can make it customized as per your application. Okay, so let's move to the first part, which is hardware selection. So what all things come under hardware selection? So the first thing is CPU. So depending on number of CPUs you have, your nodes will be able to be take a, will be able to take up parallel loads or not. So if you have 8 CPU and if you have 16 CPU, obviously the you know the load your system can take, the parallel load your system can take, it will almost double up, right? And then there's something called network, since as you know there is so much of data being exchanged between nodes. So for some of the internal purposes, like like replication, when you do the replication, some data gets moved from one node to another. And just to if you update that some data, you have to you basically prepare some Merkle trees, match them, and there is some data exchange at every point in time. So you have to plan your network well. It shouldn't happen the communication between two nodes is very slow because of the network, because of the uh, you know n- slow network, and you may end up having bad performance in that case. Disk, yes, you can make wise choice about disk, whether you go for SSDs or you want to go with the uh, spinning disk, or like how many disks per node you want to have, and so on and so on. And memory, as we know, memory also plays an important role. Depending on the memory, you can set different configuration, right? So you have a configuration for mem table. I mean, if you have more memory, you'll declare the mem table size to be more. Okay, so on it will impact the cluster performance a lot. We'll discuss each and every one in detail. So how does each and every one impacts the performance? So the first comes to memory. So let's assume you have 4 GB of memory, 4 GB of RAM. Okay, in your node, in your every node you have 4 GB of RAM, and you have X number of nodes. So in one node, there is a configuration that you set for a mem table. You say the threshold for my mem table is, say if you have 4 GB, let's say you set only 1 GB for mem table, because 3 GB was required somewhere else. So we set only 1 GB for mem tables. So as soon as mem table reaches 1 GB, it gets flushed to SS table, right? So suppose you have 10 GB of data to be written. So after each 1 GB, the mem table will get flushed to an SS table, and there will be 10 SS tables, right? So now assume your memory got increased to, say, it got doubled. Let's say it got 8 GB from 4 GB, and now you can easily allocate 2 GB for your mem table size. Now if you're writing 10 GB of data, so what will happen is it will flush the data only after 2 GB of data being written to mem table, right? So it will flush it 5 times, so that there will be only 5 SS tables instead of 10 that we had it in the earlier case. Okay, so more will be memory, you will be able to allocate more memory to mem tables, and more number of mem tables, sorry, the larger the mem table will mean fewer SS tables. And as you know, if the SS tables are fewer, you have to do less scans, and you'll have a lot of duplicated data if you have a lot many SS tables. Okay, because the data is not updated, right? It is just appended. If you have, okay, so capacity you have to decide per node. You don't want to allocate too much of space, and at the same time you don't want end up having lesser space than required. by your application. So you have to basically consider the capacity, I mean, in like very carefully. And there is second part, IO throughput. You have to plan the IO throughput. I mean, so as we know, I mean, every time you read data, write data on disk, there is some IO work happening. I mean, disk will basically run some internal processes, okay, to basically make that read and write happen on the disk. Okay, so you have to consider that IO throughput also, because every time you'll be writing to a commit log which is on the disk. So there is a lot of IO throughput involved in the disk. You have to make wise selections about your disk also, so that the IO throughput can be reduced. Performance in two way. Larger mem tables will lead to fewer SS tables, and larger cache size you can declare, which will help the query, which will reduce the disk IO for some of the reads, which will get so this way the performance will get better and better. Okay, so that's clear. Okay, so let's proceed to the next slide. Okay, disk. So while disk collection, there are two very important factors that you need to discuss, that you need to take into account. The first one is capacity. So how much disk you should allocate, or how much disk capacity you should allocate to each node. Okay, so capacity you have to decide per node. You don't want to allocate too much of space, and at the same time you don't want to end up having lesser space than required by your application. Okay, so let's go to CPU. So how does CPU impact this? So if you have insert heavy workloads, so your workload is insert intensive, there are so many inserts or so many writes happening on your system, it will be actually CPU bound in Cassandra before being memory bound, right? So basically it happens on the commit log, it doesn't go to the memory directly. So writing on the disk, it's basically CPU bound process. So more number of CPUs you'll have, the highly concurrent your system can be, highly concurrent your writes can be. Okay, so that's the benefit out of the CPU having many CPU cores. Currently, nodes with 8 CPU cores typically provide the best price to performance ratio. If you go beyond 18, that's fine. The performance still better, but the price will also increase a lot. So if you want to consider best price by performance ratio, that will reach when you use 8 CPU machines. Okay, and on virtualized machine, consider using a cloud provider that allows CPU bursting. Okay, so in network, Cassandra is a distributed data store, so it puts load on the network. So as you know, we have to exchange some data. We have to, I mean, nodes will have to basically do some gossip protocol. I mean, basically they'll be basically talking to each other. There's a lot of peer and peer communication happening, right? So the network has to be reliable. At any time, there shouldn't be any failures in the network. Okay, so and there shouldn't be many firewalls when you have different data centers maintained. So even you may have different data centers, you may have your nodes in different data centers, but network should be so fast, it shouldn't basically impact the IO. It should not impact the various processes happening in between the nodes. It can be message servicing, I mean basically exchanging the message between the node. It can be other processes like a replication that happens, or it can also be bootstrapping. We also talked about bootstrapping, wherein a new node comes and it'll sync it from the seed nodes. So that syncing has to be very fast. So that's why the network plays an important role in your Cassandra cluster's performance. So you have to plan for network accordingly. It has to be as fast as possible in your case. So what is why we want to do capacity planning? So it depends. I mean, it has two components. So first thing is you have to consider user data size. So which is nothing but your application data we are talking about. So depending on what kind of data you are storing in your application, you may estimate the size to some extent. So suppose in if you think your application size today is 1 terabyte, and in few months it will be like 5 terabytes, so you have to basically plan it on the 5 terabyte scenario, because I mean just keep it on the higher side. So you can consider the application data to be 5 terabyte. And the same thing, there is something called usable disk capacity. So what happens is, if you have a disk of 1 terabyte, you cannot store 1 terabyte worth of data on that disk. Why so? Because there are some internal processes happening on the disk that need some space, and that space is allocated to those processes. Disk basically preserves some space for some of the processes that will be happening to read and write the data. So when you're reading the data out of disk, when you're writing the data out of the disk, there are some processes happening, and that will also require some space to run. So they'll make use of the disk space. So that's why the usable disk capacity is actually quite lesser than the actual disk capacity. Actual disk capacity, as in the disk capacity that you buy from the vendor, the usable disk capacity reduces by some percentage. Okay, we'll discuss about how much percentage and all in next slides. We have detailed description. So why do we make discounts and how much discount we make when we plan for usable disk capacity? Okay, so how do we calculate usable disk capacity? So first of all, you have to calculate the usable disk space per node. Okay, so for each node you have to do it and then multiply with the number of nodes. So I'm assuming your cluster to be homogeneous. Homogeneous, I mean all the nodes are equal in terms of the configuration. Like in case of their disk and RAM, all are equal. So this is how you make the calculation. Okay, so how do you actually reach the usable disk space per node? So you have certain disk size, and you have a few number of disk on a particular node. You can have more than one disk also on a single node. Suppose, let's say your disk size was 1 terabyte and there were 5 disks on that node. Okay, so the raw capacity that we are talking about here will be 5 into 1. One is the disk size. Each disk is 1 terabyte of space, and number of disks are 5. So the raw capacity will be 5 terabytes. And then on raw capacity, we have to give the formatting overhead discount, which is basically the space that the read and write processes happening on the disk need to like basically they preserve some space for the read and write operation that are happening on the disk. Internally, there are some processes happening which basically preserves some space on the disk for internal processes, and that's why we have to give a discount of 10%. So we always assume our formatted disk space to be 90% of the raw capacity. This is a rough figure as per the industry standard, but you can always assume depending, if your reads and writes are too much, and then depending on that, you can reduce it by five more percent as well. You can make it 15%, but actually it is 10%. Okay, so as per the industry standard, we consider it 10%. So the raw capacity, if it is 5 terabyte and you multiply it by zero point 0.9, since we are calculating 90%, the formatted disk space will become 4.5 terabytes. Okay, and then, as you know, on Cassandra cluster, there are certain processes like compaction, repair disk, everything is happening, right? So compaction also, what it does, it basically creates a single SS table from multiple SS tables. Okay, so suppose you have 4 SS tables in your system, so it will create one SS table will have all that information stored in those 4 SS tables, right? This is what compaction means. So in compaction, there will be a state wherein you have the new SS table also, and you have the old SS table also, because you have to be sure the new SS table is okay, and then only you drop those previous SS tables, right? So there is a stage when it kind of duplicates the data. So once the SS table is done, once the whole all 4 SS tables are processed, then only it drops the SS tables. I mean the old SS tables. Okay, so there are some space issues or space occupied by compaction as well. So for the compaction process to run, it almost occupies the 50% of space. So we give a discount of 50% for various processes happening in the Cassandra cluster, specific to the Cassandra cluster, internal to Cassandra cluster. We give a discount of 50%. So our formatted disk space was 4.5 terabyte, and then we consider it to be 50% of that, which will come around 2.25. Okay, so as you saw, for each node, if you had like 5 terabyte of space, but the actual usable disk space out of that is 2.25. Is this part clear, Nanta? So we have an exercise to basically just see. So here's the question. Any's time. Okay, so we suppose we have 4 disks, 64 GB each, and the formatting discount that we want to give is 15%, and the compaction and repair discount we want to give is 50%. So let's calculate the usable disk capacity. So I'll give a minute for you to calculate it. and then I'll show you the answer. So if you see, if you multiply, I mean, if you so the raw, in this case, raw capacity will be 64 into 4, which will be 256, right? 256 GB is the raw capacity. Then you give formatting discount to it. It will be 15% of formatting discount, which will come around, say, 30 GB or so, right? And then you give 15% discount. So overall, it will come around some 100 something GBs. So I assume that part is clear. It's I think easier to understand also. So the approximate answer 115 GB, but here I think there's some calculation issue. So Anis has considered the formatting discount to be 10% instead of 15% in this calculation. So if you assume the discount to be 10%, so let's assume the discount is 10% here. 256 10% discount 25, and it will come around 240 GB here, and then 50% discount something close to 115. Okay. Okay, so let's go ahead with node configuration options. So what are the different options we have while we want to configure a particular node? What are the different options we have while configuring? So we have storage settings to be configured. We have partitioner settings. Okay, Shiva has also joined. Nanta is saying Shiva has also joined. Just a minute, let me just have a look. Yeah, Shiva is also there. Hey Shiva, I think you joined very late. I assumed nobody is there apart from Nanta, so I'll take care. So how do you calculate your usable disk space out of your total disk available? So this is per node calculations. Let's assume you have disk size of 1 TB and there are 5 different disks on each node. Okay, so 1 TB of disk and 5 TB of 1 TB of disk and 5 total number of disk on each node. So the raw capacity will become 1 into 5, 5 TB. Okay, and then there is a formatting overhead discount, which is nothing but when you make read and write operation on a disk. Okay, when you make read and write operation on a disk, there is some space utilized by those processes. Okay, so when you seek and read data, or there is some internal metadata maintained in the disk, which basically takes some space. Okay, so that's why the whole of 100% hard disk is not available to store the data. So that's why we have to give a discount while calculating the usable disk capacity, that is around 10% that we use. So the raw capacity multiplied by zero point 0.9, which is like nothing but 90% of it, will give you formatted disk space. So in this case, 5 TB was your raw capacity, multiplied by 90% will give you 4.5 terabyte as formatted disk space. Then there is some internal processes of Cassandra running, like compaction. Then there is repair disk happening. So all those processes also take some space on the disk. Since compaction is a process of basically combining four SS tables into one, so it also takes some space on the disk. So all I mean normally we allocate 50% of the space to these kind of processes, the internal Cassandra processes happening. So out of total formatted disk space of 4.5, we basically calculate 50% of it, which comes around 2.25, and that is the actual usable disk capacity. So out of the 5 TB, only 2.25 TB is actually available to store the application data. So let's go to node configuration. So we have different configurations to be done on each node. So as we discussed earlier, also there are certain parameters that we set in Cassandra YAML file. So what are the different settings? One is the storage setting. So storage setting is nothing but you have to give the token number and all the stuff. And partitioner setting, storage setting is nothing but you have to declare the data directories and all, where will your commit log will go, where will be your SS table stored, and all the stuff you declare under storage settings. And there's something called partitioner setting, where you actually define which partitioner to use, whether random partitioner, murmur 3 partitioner, and all that. And there are some snitch settings. So as we discussed in snitch, there are different kind of snitches available. So you'll have to define which needs to be used. That will define in Cassandra YAML file itself. And then there are some gossip settings, gossip happening between each node, which port it will happen, and all that stuff. There are certain settings that we'll discuss in later slides as well. So storage setting, a node is configured to store the data it manages in warlib Cassandra. So by default, when you install a Cassandra on your machine or anywhere, the data directory, or the cache directory, and your commit log directory is by default under varlib Cassandra. So if you don't have that directory already created in your machine, you have to create it manually so that your Cassandra doesn't fail. Okay, so under this you'll have data directory, you'll have commit log directory, you have some saved cache directory or something like that.